Okay, this video is on special factorization, and we will be solving this polynomial, but first we're going to do a quick example. So here's our special factorization rule, and there's actually a bunch of different rules. Let me pull these up. These are good to have memorized. I could put the URL here in the comments, but take a look at these, kind of play around with them, do the FOIL, and see if you can get them yourself. So this is the one we'll be using today. X plus y squared equals x squared plus 2xy plus y squared. So here's a simpler example. If we can find something in the form x squared plus 2xy plus y squared, we can easily factor it to this. So the thing to notice here is that our x squared is x squared. That's pretty easy to see, so it relates to the x. Our y squared here is a little more tricky, but we could write the 9 as 3 squared. And you could also write the middle as 2 times 3 times x. So you can see that we have this y squared, which is the 3, so y is 3, and then the x is x. So 2 times x times y, and you have the x squared. So you can easily write this as x plus 3 squared. And that's why this rule is helpful. Now let's look at something a little trickier. This one's really tricky. So whenever you see a multiple of 2 in the exponents, we're going to want to kind of do a trick like, well, we're going to say that x squared, in this case, equals a to the 4, and that would imply our x equals a squared. So that's kind of the trick we're going to be using here. And in addition to this, this trick, well, we need to account for the coefficient. So actually this has a coefficient, so we can say, well, this first term, we want that to look like x squared, right? We want this to look like this. So we want to be able to write this as x squared minus, so again, I pulled up kind of the wrong rule, so let's just look, that's a minus 2ab plus b squared equals a minus b squared. And that's kind of what we have here. So let's change that to a minus, and that to a minus. And that's what we'll have. Okay. So we want this x squared to look like this. So we're just going to write the equation x squared equals 1296 a to the 4th. And well, if we take the square root of both sides, because we want the value of x to put here, we're going to have x equals, well, what's the square root of 1296? You can use a calculator here. So let's try to find something squared that equals 1296. Let's just guess 15. Let's see what 15 times 15 is. It's 225. Okay, that's too low. Let's try something higher. 25 times 25, 625. Okay, we're getting closer. Let's try 30 times 30. 900, closer. 35 times 35, 1225. Really close. So let's see, 36 times 36, 1296. There we go, 36 squared. So now we can write 36a squared squared. Oh, no, sorry. That's right. So when we take the square root of both sides, this is what we should get, is 36a squared. So we just took the square root of both sides, and now we have our x value. That's literally what we'll be putting in here. So let's get our y value. So y squared should equal 625b squared. And actually, that was one of the things I think I guessed and checked. I'm not sure what it was now. 15 times 15. 225, no. 25 times 25, 625, there we go. Okay, so then we have y, if we take the square root of both sides, we have y equals 25, 25b. Okay, so now we have our x and our y. We just have to make sure that 2xy is, did I actually copy this problem wrong? Let me just take a look. Okay, sorry, I copied this problem wrong. This should be to the fourth. So just change that, and that would make this squared. Okay, so now we just have to check that 2xy is 1800 ab squared. So just to check, we have 36 a squared times 25 b squared. Let's do that on our calculator. 25 times 36, 900. Right, that's exactly what we want. We want 2ab, right, 2xy to equal 1800 ab squared. So 2 times 36 times 25 does equal 1800 a squared b squared. So that's right. So now we just simply have to write x minus y squared, and we have our x and we have our y, so let's write x minus y squared. We get 36 a squared minus 25 b squared equals this. And there, we have factored, oh, this should be a squared, right? It just looks exactly like the rule we just used. And there you have it. We factored x minus y squared equals x squared minus 2xy squared. And just remember that it doesn't matter whether we have this a squared still here. And you might actually be able to factor this more. Actually, I didn't think about that. Can we factor this more? Is this in the form we can factor? Let's actually look at our rules again. Aha, a squared minus b squared equals this. So we can actually keep going on this. Let's do that. So our new rule is a squared, or let's write it in x and y. X squared minus y squared equals x plus y times x minus y. So again, let's write out what our new x's and y's are. So if x squared equals 36a squared, if we take the square root of both sides, we get x equals 6a. Let's do the other one. 25b squared equals, oh, well, y squared. This is a new y squared, right? So y squared equals 25b squared, and y equals 5b. Okay, so let's use that rule and write this out. So we have this squared, so we'll keep a squared there. So copy this. This equals so first actually let's write this out. So this has a squared. So we can write this equals, well, that's the definition of squared is just itself times itself. And now this thing, we said that one of these, right, one of these can factor into 6a plus 5b times 6a minus 5b, right? That's what we did here. So then if this is squared, right, that's what we have here. This is squared. So that this whole thing equals this twice. We'll have to make this longer to see it all. So that means this factors to this, which factors to this. So our final answer should be along the lines of this, or if you want to write it in squared, you could just put a parentheses around this whole thing and write squared. So using two different special factorization rules, we were able to completely factor it. And that should be it.